Hello, everyone. So let me get my screen shared. Okay, so in our first slide here, you can see that the medication that over here, the half-lives that have been lost. So the question was asked, how many times can you divide a number? The answer is that it would be infinite. So it is, you can divide a number times whatever. I mean, it can have 600 zeros on it, but you can divide a number. It's just infinite. So there's no limit to how many times you can divide a number in half. A trend line can be used because we can plug any number into Excel and it instantly give you the results. So I'm new to the whole Excel thing, but I've grown to enjoy it, and it really is. It's very nice to use, and I mean, you just plug in the numbers, and so a trend line can help you in that way. And then there can be a multiple, it can be multiple numbers per line. This one right here is horizontal, as you can see, but there can be vertical. There can be more than one per a graph. So, but each of these are the exact same. The E and the numbers here stands for exponent. So that's 600 to the 0.93 power. So, yeah, but like I said, you can divide or you can half these numbers. I mean, all these numbers can be halved. So there's no limit to how many times you can half it. I mean, so like you can see here, I will just show you a little example. I mean, you just go on down and you can just see it keeps on just dividing it and dividing it and dividing it. So, yeah. So we're going to go on to number 2. So here, get to the top. I kind of have a different perspective on all this. So I come from a farming family. My grandfather has been a farmer his whole life. He's farmed thousands and thousands of acres. My dad grew up on the farm, and he thought that's what he was going to do. But later on in life, he changed his career. But so I'm kind of partial towards the farmers. I do agree that not all farmers do everything that is right. But so I have to kind of take that in consideration when I'm talking about it. But so you can see that over the years, there has only been more and more crops grown because there's more and more demand for them. But the health problems have grown worse as well. I personally don't think it's all because of the chemicals, because the research, there's so much more research that are going into this stuff now. I do still think that I have personally have researched it myself more than just here. I have done it in the past. And I don't think that enough time has gone by to show all that needs to be shown yet. Time will tell. But so we'll look at the graphs here, but I'm just going to go ahead and tell you that I'm a little partial to the farmers. But I mean, so the number of children here, it only goes up to 2010. So, and then the deaths due to the infection. These graphs were a little hard to copy, so I hope I got everything right. So as you can see, from 1990 to 2010, which each of these graphs have the same years for the most part. This first one has 2012, but for the most part, everything else is 2000 or 1990 to 2010. So as you can see here, the line goes up, and there's, as it shows here, it's really been an increase since 2005. So, and then these deaths per 100,000. So that's a bunch. The hospital discharge, it has gone up as well. It's not near the numbers that the other one was, but the arthritis one, it has doubled since 1990 to 2010. So it is on the rise. I mean, that's 20 years. So, but again, I will say I don't think all of the diseases are from the chemicals. I know a lot of people don't agree with me. But and this one right here is against the plot. So this from 125 to 550. Again, in a 20-year span. So the acres are in orange here, and then the blue is the number of diagnoses. So, but like I said, I do think there needs to still be more research, and there is being research done. So hopefully we'll have more of an understanding in a couple years. But like here it shows the blue is the corn and soy. The orange is just the soy. And then the gray is cotton only, and the yellow is the corn only. So here's that. The loss of life. Some of these numbers were quite devastating. So here it shows that the fatalities have fluctuated over the years. Because here in 2014 there was 46, and it goes up to 54, and then back down to 35. So the 5-year average is 43. But also here you can see that males were 24 in 2018, and then 2019 it's 40. So it's almost doubled. So there's been an increase. Females have gone up just a couple. So you can see over here as well, drivers change is 37%. So, and like I said, over here is 83%, so almost doubled. But as you can see here, this is for road users of 2018, 2019. So as you can see that the driver has gone up in 2019 more than 2018, and the motorist, cyclist. So everything has pretty much gone up. It was interesting to see here the road user 5-year average in the passenger. It is more than anything here. So go on down. As you can see here, more deaths occur in the 70-year-olds. Again, this is in the age group of 2019, than any other year. So that's pretty interesting to see. But yeah, so the 70-year-olds have the most. And then we'll scroll down. So the blood alcohol here, yeah, it's quite staggering that the median, is 2.4, and the mean is 2.36. So basically the same. And then let's look at this. So this is a pretty cool diagram. The alcohol is 9.7%. Cannabis was 3.7%. Other drugs were 10%. And medications was 19.9. And then the negative of all substance was 59.9. So that's a big number. But as you can see, they overlap there. So I don't think that the rules in British Columbia would work in the United States, simply because the British Columbia is so much smaller. In the United States, it has 50 states. And even now, not all laws are the same in each state. So I don't think that the British Columbia law would be able to be applied to all 50 states of the United States. Maybe to one, but I don't think to the whole United States. So, and then I also think that driverless cars are the future. I think that's going to, one day, I mean, as crazy as everything is, but I think one day that will probably be the case. It will be interesting to see how that works out, because I know right now a lot of the driverless cars, have had wrecks and different stuff, but I'm sure they'll be able to get it fixed. My only concern was if everybody could afford them, but I'm sure that bridge will be crossed when we get there. So right here we're going to be talking about mean, median, and mode, and the age brackets. So as you can see here, over the years, it's pretty much been going down, except for the 70 plus. They have just been it's a very gradual, it's about the same. It's gone up and down a little bit, but not much. So it's gone from like 1% to 0.9. So it's just been very slight. So here you can see that the median is 6.2, and this is in the age bracket of 16 to 24. And this is data on texting and driving. And so this is a box and whisker plot. And you can see that the 6.5 is the X is right there. So that's pretty neat. I love box and whisker plots because I think they show a really neat side of graphs that not all other graphs show. And here is the bell-shaped curve. And it's also, you can tell, 6.1. And then this is the age bracket 25 to 69. And you can see that the median here is 4.9. And then the standard deviation is 0.01. I mean, you can see here that the line goes through right around the 5 marker. It's a little below, so 4.9. And then the bell-shaped curve as well. And then the last one is age 70 plus. The mean and median is 1.1. So here, you can tell the dots fluctuate a lot more than the ones above. So like these are more of a steady line. These fluctuate quite a bit. And then the line is right above the 1 mark. So it is right at 1.1. And then the bell-shaped curve. So the coefficient of variation is a measurement of how spread out the data is. So you can see here we have coefficient of variation. And so that tells you how spread out the data is. The standard deviation is used to qualify the amount of variation in a set of values. So we'll go on to the next. And this is distribution of wealth in the United States. As you can see here, I liked how we were able to do these two charts, because if you can just visualize, you can see here that there's very slight blue on these here, and then they go up to orange. But if you can picture basically the orange just sliding on top of the blue, it equals the chart on the left. So I really liked how these are the exact same numbers, just in different charts. They're both bar graphs. So you get 1% here is very, owners in the United States own more than the household. So, and then the federal taxes, where do our federal tax dollars go? So this is a pie chart, and as you can see, I think we determined that the most goes to Social Security, and then the most goes to, Medicare, and then Social Security, defense, and then it just goes down from there. And then when you throw an outliner in a mean or median, you're not going to be able to, it's completely different. So as you can tell here, In this one that we were able to snip in here, you just cannot get a mean, or it will be totally different. She did, our instructor said something about the education only being 2% here. So whenever I went to look up the state sales tax, I assume this is right, but it only shows that it's 3.5%. So it's just a slight more our state than our federal going towards education. And I do think there needs to be more going towards education. But I tried my best to get a accurate graph on this, but so you can see here, this equals up. Total spending was the most over here, and then it went to healthcare, and then public debt. So then on to the next. This is our last slide, and this is talking about the rise, of how the taxes affect the different, how you file them. So we have head of household, single, marriage, filing, or jointly. So the head of household, as you can see here, their annual pay is $50,000. It is deducted 19%, so they had to pay $10,810, and this is what they had left over. But if they just got a $2,000 rise, they ended up with less. So you have to determine if you really want a raise or not. Sometimes it's worth it. Sometimes it's not. It just depends on if you have to go over in the next bracket on the taxes. But each person has to determine that for themselves. So, as you can see in this graph, the orange is the new pay. So what you have left over is significantly less than if you had just kept the other. So each person has to decide that themselves. The married and jointly, they don't take as much out. So you can see that you have some left over, more left over in the than you did up here. And then over here, singles, they don't have to pay near as much either. So it's only 29% deducted. So both of them are. So, but I do think that they might not, it might not vary as much in singles because this is counting single mothers as well. So I don't think that the money going over, there's more of a gap before you have to start paying more taxes. So, well, that's going to be it for my Zoom. I hope everyone has a great week, and I will see you all again shortly.